So here in this question, we have to determine the limiting value of the given function when x approaches 3. So we begin by doing a direct substitution for the value of x. So we have 1 over 3 minus 3 minus 2 divided by 3 squared, which will be 9, minus 4 times 3, that will be 12, plus 3. So this gives us 1 over 0 minus 2 over 0. So we have infinity minus infinity. Now this is an indeterminate form. So we need an indeterminate form of 0 over 0. So what we are going to do, we are going to combine these two rational functions first. So let us begin by rewriting the given rational function. So we have 1 over x minus 3 minus 2. Now what we do, we're going to split the middle term of the rational of the polynomial, of the quadratic polynomial in the denominator of the second rational function, and that will give us x minus 3 times x minus 1. Now we combine this, so that will give us limit x going to 3. Now combining in this sense, I'm going to pull out 1 over x minus 3 as the common factor, so that leaves us with 1 minus 2 over x minus 1. So we have limit x going to 3, 1 over x minus 3 times x minus 1. So we cross multiply 1 with x minus 1, so that will give us x minus 1 minus 2. So we have limit x going to 3, 1 over x minus 3 times x minus 3 over x minus 1. Now when we substitute the value of x, so that will give us an indeterminate form of 0 over 0. So this 0 over 0, this indeterminate form is occurring because we have x minus 3. That's the common factor present in both the numerator and the denominator. So what we're going to do, we're going to get rid of it by cancelling it up. So we have limit x going to 3, 1 over x minus 1. Now we use the value of x, substitute, that gives us 1 over 3 minus 1, which is equals to half. So this is going to be the limiting value of the given function when x approaches 3. So here we have a function and we need to find its limiting value when x approaches 2. So we begin by substituting the value of x by 2. So we have 2 divided by 2 minus 2. Minus 4 divided by 2 squared, which is 4, minus 2 times 2, which is 4. So this gives us 2 over 0 minus 4 over 0, which will give us an indeterminate form of infinity minus infinity, and we need it to be in the form of 0 over 0. So what we are going to do, we are going to do some algebraic manipulation here. So let's rewrite it as limit x going to 2. So we have x divided by x minus 2 minus 4. So we are going to take x as the common factor, so that leaves us with x minus 2. Now we are going to factor out 1 over x minus 2. Then the first term will be x minus, and the second term will be 4 over x. So let us now combine x going to 2, 1 over x minus 2. So we have x as the common denominator, so x times x will become x squared minus 4. Now x squared minus 4 can be further broken down by using the identity a squared minus b squared gives us a minus b times a plus b. So x squared minus 4 can be written as x minus 2 times x plus 2 divided by x. Now when we do a direct substitution for the value of x, so that will give us a 0 over 0 indeterminate form. So let's check it out. So we have 1 over 2 minus 2 times 2 minus 2 times 2 plus 2 divided by 2. So we have a 2 minus 2, which will be 0. So 0 times 2 plus 2 will give us a 0 in the numerator. Similarly, we have a 2 minus 2, which will be 0. And 0 times 2 is also going to give us 0. So we have a 0 over 0, which is an indeterminate form. And that is occurring because we have the factor x minus 2, which is common to both the numerator and the denominator. So we're going to get rid of it. So we have limit x going to 2. So that leaves us with x plus 2 over x. Now we're going to substitute for the value of x. So that will be 2 plus 2 divided by 2. So we have 4 over 2, which gives us 2. So the limiting value of the given function when x approaches 2 is going to be equals to 2. So this question is quite similar to the previous one. So we begin by first substituting the value for x. So we have 1 over 2 minus 2 divided by 2 squared, which will be 4, minus 2 times 2, that will be 4. So we have 1 over 0 minus 2 over 0. So this is giving us an indeterminate form of infinity minus infinity. So we will do some manipulation here. So we have limit x going to 2, 1 over x minus 2 minus 2 divided by, so we're going to take x as the common factor, so that leaves us with x minus 2, which will be equals to limit x approaching 2. So now we are going to take 1 over x minus 2 as the common factor, so that leaves us with 1 minus 2 over x, which will be equals to limit x going to 2, 1 over x minus 2. Now we're going to combine 1 and 2 over x. So we have a common denominator of x. So x and 1 gets multiplied. That gives us an x minus 2. Now when we substitute for the value of x, so that gives us an indeterminate form of 0 over 0. So what we're going to do, we're going to factor out x minus 2, which is common to both the numerator and the denominator. And that leaves us with limit x approaching 2. So we have 1 over x. So that will be 1 over 2. So this is the limiting value of the given function when x approaches 2. So here in this question we have to determine the limiting value of the given function when x approaches 2. So let us multiply the factor x squared minus 9 to each of the rational functions. So that will give us x squared minus 9 over x plus 3 plus x squared minus 9 over x minus 3. So we have limit x going to 3. Now x squared minus 9 can be factorized as x minus 3 times x plus 3 divided by x plus 3 plus x squared minus 9. So for the second rational function we have x minus 3 times x plus 3 divided by x minus. So here we are going to get rid of the common factors from both the numerator and the denominator, and that will leave us with limit x going to 3. We have x minus 3 plus x plus 3. So the 3 and negative 3 will cancel out, so and that will leave us with limit x going to 3 twice of x, and using the limiting value of x, so we have 2 times 3, which is equals to 6. So this is going to be the limiting value of the given function when x approaches 3. So here we have to find out the limiting value of the given function when x approaches 2. So let us begin by doing a direct substitution. So we'll get 1 over 2 minus 2 minus 2 times 2 is 4. So we have 4 minus 3 divided by 2 cubed. So that will be 8 minus 3 times 2 squared. So that is 4. So 3 times 4 will be 12 plus 2 times 2 will be 4. So we have 1 over 0 minus 2 times 1, which is simply 2, divided by 0. So this is giving us an indeterminate form of infinity minus infinity. However, we need an indeterminate form of 0 over 0. So let us do by rewriting the rational function. So we'll have limit x going to 2, 1 over x minus 2, minus of 2 times twice x minus 3. Now we see that there's an x We can factor out actually x from each of the terms of the denominator. So we have x multiplied by x squared minus thrice x plus 2. So we'll have limit x going to 2, 1 over x minus 2 minus 2 times twice x minus 3 divided by x. So we're going to factorize x squared minus thrice x plus 2 by splitting the middle terms. So that will give us x minus 2 times x minus 1. Now we are going to factor out 1 over x minus 2 from each of the two rational functions. So that would leave us with 1 minus 2 times 2x minus 3 divided by x times x minus 1. Now we are going to combine the two rational functions. So that will give us limit x going to 2, 1 over x minus 2 multiplied by, so we'll have a common denominator here, x times x minus 1. So we'll multiply the denominator with 1, so that will leave us with x times x minus 1 minus 2 times 2x minus 3. So we have limit x approaching 2, 1 over x minus 2. Now we distribute x with x minus 1, so that will be x squared minus x minus 4x plus 6 divided by x times x minus 1, which will be equals to limit x going to 2, 1 over x minus 2 times x squared minus 5x plus 6 divided by x times x minus 1. On further simplification, we have limit x approaching 2, 1 over x minus 2. Now we have a quadratic polynomial in the numerator, so we can again refactorize it by splitting the middle term. So that will give us x minus 2 times x minus 3 divided by x times x minus 1. Now when we substitute for the value of 2, so we'll have a 2 minus 2 in the numerator, so that will make it 0. So the entire numerator will become 0 divided by, we also have x minus 2 in the denominator, so that will become 0. So 0 multiplied to x times x minus 1 will give us 0. So we have a 0 over 0, an indeterminate form. So what we are going to do, we are going to factor out x minus 2 from both the numerator and the denominator. So that is going to leave us with x minus 3 in the numerator and x times x minus 1 in the denominator. Now we substitute for the value of x. So we have 2 minus 3 divided by 2 times 2 minus 1. So 2 minus 3 will be negative 1 divided by 2. So this is going to be the limiting value of the given function when x approaches 2. So this question is quite similar to the previous one. So we have to find the limiting value of the given function when x approaches 1. So substituting the value of x gives us the infinity minus infinity indeterminate form. So we begin to do some algebraic manipulation here. So we have limit x approaching 1. So the first term will become x minus 2 divided by, so we have x squared minus x. So we're going to factor out x, and that will leave us with x minus 1 minus 1 over x times x squared minus 3x plus 2. Limit x approaching 1. So we have x minus 2 divided by x times x minus 1 minus 1 over x times, so we're going to factorize x squared minus thrice x plus 2. So that will give us x minus 1 times x minus 2. So we have limit x approaching 1. So now what we are going to do, we are going to factor out 1 over x times x minus 1 from both the two rational functions, and that will leave us with x minus 2 minus 1 over x minus 2. Now let us combine these two rational functions. So we'll have limit x approaching 1 over x times x minus 1. So we'll have a common denominator of x minus 2. So we have x minus 2 whole squared minus 1. Limit x approaches 1. We have 1 over x times x minus 1. So x minus 2 whole squared is the identity. So that will become x squared minus 4x plus 4 minus 1 divided by x minus 2, which will be limit x approaching 1 over x times x minus 1, and we have x squared minus 4x plus 3 divided by x minus 2. Now we are going to factorize the numerator. So we have x approaching 1 over x times x minus 1. So factorizing the numerator, so will give us x minus 1 times x minus 3 divided by x minus 2. Now when we substitute the value of the limiting value of x, which is 1, so that will give us x. We have an x minus 1 in the numerator, so that will be 0. So we have 0 in the numerator. Since we also have an x minus 1 in the denominator, so that will give us a 0 in the denominator. So now we have a 0 over 0 indeterminate form, so we can proceed further. So this is happening because we have x minus 1 common to both the numerator and the denominator. So we factor it out, so that leaves us with x minus 3 in the numerator divided by x times x minus 2. So now we substitute the value of x. So we have 1 minus 3 divided by 1 multiplied to 1 minus 2, which is equals to negative 2 divided by negative 1. So the limiting value of the given function is 2 when x approaches 1. So here we need to determine the limiting value of the given function when x approaches 1, and there's a condition that the value of x is greater than 1. That's because for all values of x greater than 1, the value within the square root will be positive, and that will make it real. So we'll have to be careful about that. So now we are going to do a direct substitution of x. So we have square root of 1 minus 1 plus square root of 1 minus 1 divided by the square root of 1 minus 1. So this is giving us an indeterminate form, which is 0 over 0. So let us do some algebraic manipulation here. So we have limit x going to 1. So we can rewrite x squared minus 1 as x minus 1 times x plus 1 plus the square root of x minus 1 divided by, so we do the same thing to the denominator. So we have square root of x minus 1 times x plus 1, which will be equals to limit x approaching 1. Now we can separate the square root. So we have square root of x minus 1 multiplied to the square root of x plus 1 plus the square root of x minus 1 divided by the square root of x minus 1 times square root of x plus 1. So here we have used the fact that the square root of a and b is equals to square root of a times the square root of b, provided a and b are both positive. So now we can take limit x approaching 1. So we can consider square root of x minus 1 as the common factor. So that will leave us with square root of x plus 1 plus 1 divided by square root of x minus 1 times square root of x plus 1. So now we're going to get rid of the square root of x minus 1 from both the numerator and the denominator, and that is going to leave us with limit x approaching 1. So we have square root of x plus 1 plus 1 in the numerator divided by square root of x plus 1 in the denominator. Now let's use the limiting value of x. So we have square root of 1 plus 1 plus 1 divided by the square root of 1 plus 1. So this will be equals to square root of 2 plus 1 divided by square root of 2. Or we can rewrite it as 1 plus 1 over square root of 2, and 1 over square root of 2 will be simply equals to square root of 2 over 2. So this is the limiting value of the given function when x approaches 1.